Topic 7, waves, like this. Part 1, basics of waves. Waves are energy, and they can be mechanical waves or electromagnetic waves. Mechanical waves require a medium, such as air, to travel through. They cannot travel through vacuum. Examples are most waves actually. Sound waves, water waves, and earthquake waves or seismic waves. Now, electromagnetic waves travel through vacuum. These include the whole electromagnetic spectrum going from radio waves right through to gamma rays. There are two categories of waves. One is transverse and the other one is longitudinal. A transverse wave is where the particles in a wave vibrate perpendicular to the direction of energy travel. Remember the definition? Examples of transverse waves include most waves, except sound waves, which are longitudinal. Look at this diagram here. This wave is traveling to the right, but each particle is moving perpendicular to the direction of travel of the waves. Now we come to longitudinal waves. A longitudinal wave is one where the particles vibrate in the same direction as the travel of the wave. Definition. Examples are sound waves. You can see here that the wave is traveling along to the right and each particle is vibrating from left to right like this. Make sure you look up the dictionary and copy down the definition of these terms to do with waves. Displacement and amplitude. While a wave is traveling along this way, each particle is moving this way, and the distance moved by each particle is called displacement, and the maximum displacement is called the amplitude. These words here are explained in simple terms, and therefore these simple explanations are not to be taken as formal definitions. There are three formulas for waves. These two are specific to waves, but this one is a general formula, which says velocity is equal to displacement or distance divided by time. Make sure you memorize them. You have to know how to derive this formula for waves. You start off with the general formula that says velocity is equal to displacement over time. Now the distance covered by one cycle of wave, like this, is called a wavelength. And the time taken by one cycle of wave is called a period. So here's the distance, here's the time. Put these two into here, you get that. Now we substitute this equation into here and we get that. So the final form of the formula is like this. Here is a simple example that requires the use of this formula here. So the final answer is that. Here is a slightly harder example that requires you to use two formulas, and it gives you the final answer like this. Displacement, distance graph. Displacement, as explained earlier, is the distance moved by each particle like this. Whereas distance here means the distance traveled by the wave going that way. It shows what a wave looks like at a particular point in time. It's like taking a snapshot of the wave at a particular point in time. Displacement time graph is very similar to displacement distance graph, except here we have time base, not distance base. And this graph shows the oscillations or vibrations of a single particle over time.